Okay, so we have case 7.
So the patient is Jeanette. She runs a small dog breeding business, and she has continued to get multiple complaints from customers that puppies they have purchased from her keep getting recurrent infections that continue to stay for a while. This is cause for concern because this occurred at the same time her breeding kennel came up with an illness. Jeanette uses an A-line breeding strategy to breed prize-winning Welsh Terriers. Line breeding is a strategy where breeding is close with relatives to keep traits they like. All the puppies are kept in a very isolated place, so they will not easily be exposed to illnesses. This can actually be connected to quarantining with COVID. She also vaccinates each of the puppies herself.
Haha, still on mute. So 3 owners of the puppies from the same litter of 6 had contacted Jeanette with concerns that their 8-month-old dogs had been contracting infections repeatedly. The first was from Snookers, a female who was diagnosed with Klebsiella pneumonia. The next was Fluffykins, who was a male, and he had 2 episodes of clostridial sepsis and transient erythematous rashes. And the third dog was Griffin, a female, and she was treated for systemic colibacillosis and pneumonia. If you look at the next slide with the dad, Roscoe, he had a history of ulcers, anorexia, polyuria, polydipsia, and high levels of blood urea nitrogen, which is a symptom of kidney failure. But the mom was reported healthy.
That was muted as well. So in this slide, this is the table that you guys saw in the article. So I'm just going to kind of explain it. So when they did their blood work, and then this is the blood work that they got back. You can see the components on the left side, and then each of the 3 puppies that were that came back to Jeanette and said that they were ill. That's their work, and then the normal levels of what each of these should be are on the right. If you look, you can see that there's many components: C1, C4, C2, etc. But C3 on the left is what is shown as extremely low. If you look all the way on the right, it's supposed to be in the upper 2000s, and it's actually in like the lower 200s area. And that's just showing it's extremely low in the puppies. And so C3 is actually really necessary to the function of all the complement pathways. And that's just going to be explained later in detail, but this is just showing that C3 is really low. So there are 3 pathways of the complement activation. All of them are initiated in some way as a part of the innate immunity system, which we talked about in class. And we're going to explain each 3 pathways separately, and then at the end put it all together. So the first pathway is the classical pathway. And you can see that the top, the C1q initiates it. So the pathway is initiated by antibodies bonded to antigens. So this C1q, that's this is what detects the antibodies. And then it binds to the FC portion, which we talked about in class actually. The FC portion is this C1r and C1s. And then it initiates the cascade to involve the other proteins, which is all kind of down here. So then moving on, we have the lectin pathway, and that is which it's initiated from the plasma lectin or the mannose binding lectin, this MBL, and then it binds to the mannan-binding lectin associated serine protease, which is the MASP1 and MASP2. And that's kind of the C1R and the C1S that was in the last slide in the classical pathway. And then C3 gets involved over here. It binds to the C3b. And then we have the alternative pathway. This is activated by microbial cell surfaces. And then you can just see in the pathway, C3 is just doing everything basically. C3b, C3a, it's just really involved in this one pretty much. It's binding to everything. And so then here's it all put together. We have the classical, the lectin, and then the alternative. And you can just see that C3 is like everywhere all over this whole system, this whole process, each of these complement pathways.
All right, the kidneys function like a filter. Therefore, kidney failure is when the filter cannot function anymore due to it being clogged. In regards to how C3 deficiency leads to kidney failure, if C3 is not working, then the system won't function, which leads to clogging and results in, of course, kidney failure. Now to break down the second question of why it is likely to have a hypersensitivity response when complexes are large. To start off with, hypersensitivity is when too much inflammation is occurring. Therefore, if the complex that is passing is too large, there will be a hypersensitive response. In type 3 hypersensitivity, as mentioned in the bullet point, that something is known as the immune complex, and which will be shown on the next slide. A symptom of type 3 hypersensitivity is kidney failure due to the clogging, and like mentioned earlier, if the entry point becomes clogged, it will not function and will result in kidney failure. Here's a visualization of what was talked about in the last slide. The glomerulus is the location of the system that is being talked about. So if you look at the top diagram where the star is, this is where it goes through, which means when it is too large, it will clump up or clog this entry point.
So when there's no C3 present, it's very bad because, like Krista said earlier, it's involved in every aspect of the processes. The system is directly involved, is now compromised, and the system tries to supplement the protein, but that's not a good resolution because it's not going to be able to make the quantity that's needed in enough time. So without having that C3 present, it's fatal to the dogs and they don't have a high survival rate, and most will die soon after birth. Looking back at this chart here, is showing us C2. And when C2 is less important per se than C3, it's not very prevalent. So that means having less of it is not going to affect the process as much as not having any C3 present. And if you bypass, or if the system bypasses making C2, it's not going to do anything to the dogs because it's not that important, basically.